In today's notes, we will explore the properties of the plasma membrane. Now, you may not recognize that name, but as you look at the cell, you see that outer membrane and you think, that's a cell membrane. It's the boundary between the inside and outside of the cell. And you may recall that the role of the cell membrane is to control what can enter and exit the cell. We often describe the cell membrane as being selectively permeable. Now, permeability describes the ability for something to move through or enter and exit. So the cell is selective in that only certain things are permitted to move across that cell membrane. It's picky. This property is what allows the cell to maintain homeostasis. As you can see, this selectively permeable membrane only allows some of these smaller particles to cross the membrane while keeping other substances on the outside. So you've already heard me refer to the cell membrane as a plasma membrane. It's also known as the fluid mosaic model and the phospholipid bilayer. What exactly do these terms mean? Well, we describe the cell membrane as the fluid mosaic model because it's made up of a number of little pieces that create an almost artistic flair. We refer to these mosaics like little tile pieces that build together, where you create one large piece with many small components. So that phospholipid bilayer or cell membrane has many little components to it. Additionally, we describe it as being fluid. When I think of something that's fluid, I think liquid. There's that ability to flow and move, which is also the case for the cell membrane. These little components that make up the mosaic are able to move and aren't locked in place. They can move right to left. They can even flip-flop to opposite sides of the membrane. Now, when we refer to the cell membrane as the phospholipid bilayer, we do so because we note that the membrane looks like a sandwich with a top half and bottom half. Bi means two. There's two layers to the cell membrane. Phospholipid is reference to one of the most repetitive and common features of the cell membrane. They look like this little head or balloon with two tails. They're the phospholipids that make up the membrane. Also interspersed within the phospholipids, we see proteins and cholesterol. So let's take a look at these components in a little better detail. That phospholipid has some unique properties that allow it to permit some things to cross the membrane. The head is this large end of the molecule, and uniquely, it is hydrophilic. Hydro meaning water. Philia means to like. So they are attracted to water. So they'll often face outside of the cell where there's liquid in the extracellular fluid, or they'll face inside of the cell where there's water in the cytoplasm. And on the other side of the molecule, you see these hydrophobic tails. Hydrophobia means that they're fearful of water. They avoid it, so they turn their tails to the inside of the membrane, the inside of the sandwich, so they can stay away from the water. That end of the molecule is considered nonpolar, and it will not dissolve in water. Now, because we have that change in hydrophobic and hydrophilic, this helps push things across the membrane. So that orientation is extremely important in its function. Primarily, this format allows for water to dissolve across the membrane. Not always is it so easy for things just to squeeze through those phospholipids. In some cases, the cell membrane requires other structures known as transport proteins to support the movement of molecules in and out of the cell. Channel proteins look like a tunnel, and they really allow larger molecules or molecules that are hydrophobic or charged to be able to cross the membrane. In other circumstances, we rely on something called carrier proteins. These use pumps and energy to help push things through the membrane. We will explore these two proteins in greater detail in our next lessons as we explore passive and active transport. Now, not all proteins are going to move all the way through the cell membrane. We also see that there are a few smaller membranes that hang out on the outside edges of the cell membrane. We refer to them as peripheral proteins. They're like golden arches at McDonald's. They're that sign that helps identify the cell membrane uniquely as to what type of cell it is. So they aid in cell communication. And finally, we note that cholesterol makes up the cell membrane as well. Now, cholesterol, you may have heard that before